Hey everyone, and welcome to today's Explainer. I am so excited to have you here. Look, if you've ever stared at your math homework and felt just a little bit overwhelmed, don't worry, you are in exactly the right place. Today, we're going to unlock the mystery of square numbers together. We're going to take it step by step, keep things really simple, and I promise you, by the end of our time together, you're going to be a total master at this. So let's just dive right in. Here is our quick roadmap for today. Number 1, visualizing the square shape. Number 2, discovering square numbers. Number 3, using squared notation. Number 4, avoiding common mistakes. 5, perfect squares in life. And 6, revision and exam questions. All right, let's kick things off with section 1, visualizing the square shape. Before we even touch the numbers, we need to talk about the actual shape of a square. I want you to picture something you see literally every single day. Maybe it's a window pane, a floor tile, or even the spaces on a chessboard. So what actually makes those shapes a square? Well, a square always has 4 perfectly equal sides and 4 right angles. Those perfectly straight 90-degree corners. Basically, if those 4 sides aren't exactly the same length, it's just not a square. Now that we know what the outside lines look like, I have a really fundamental question for you. What is area? Think of it like this. If the outer sides of the square are a fence, the area is the grassy space inside that fence. It's the total amount of space contained inside the shape. So keep that in your head. A square has equal sides, and its area is all the space packed inside. Let's see how that actually connects to our numbers. Moving right along to section 2, discovering square numbers. We are going to find the area of squares just by counting. Imagine a tiny square where each side is just exactly 1 unit long. Inside, there's just one single square, right? Because 1 times 1 equals 1. Now picture a slightly bigger square where the side is 2 units long. If you draw grid lines inside it to fill it with those tiny unit squares, you'll count exactly 4 small squares inside. 2 times 2 equals 4. Do the same thing with a side of 3 units, and you'll count 9 little squares inside. 3 times 3 is 9. Bump that side up to 4 units, and suddenly you've got 16 little squares. Now check this out. Look at the pattern happening here. When the side is 1, the area is 1. Side 2 gives an area of 4. Side 3 gives 9. Side 4 gives 16. And side 5 gives 25. Are you starting to see where this is going? Every single area is just the side multiplied by itself. This beautiful, predictable pattern is exactly why we call these square numbers. They quite literally make a physical square shape when you draw them out. So here is our formal definition. A square number is the product of a number multiplied by itself, like 5 times 5 equals 25. But hey, you don't need to just blindly memorize that sentence because you've just seen exactly how it works with your own eyes. Just remember, when you multiply any number by itself, you are creating a square number. Okay, let's jump into section 3, using squared notation. Mathematicians really love finding shortcuts to save time. So instead of writing out 5 times 5 every single time, we just write the normal number 5 and pop a tiny little 2 at the top right corner. That tiny 2 is our symbol for square. So whenever you see it, you just read it out loud as 5 squared. It means the exact same thing as 5 multiplied by 5. If you see a 10 with that tiny 2, you say 10 squared, and you instantly know it means 10 times 10, which is 100. It's basically just a fast, clever way to say, hey, multiply this number by itself. Time for section 4, avoiding common mistakes. You're going to want to pay close attention to this one. I really need to warn you about a super tricky trap that catches a ton of 8th graders on their exams. People see that tiny 2, and their brain automatically goes, oh, just multiply the big number by 2. They think 5 squared means 5 times 2, which is 10. Actually, scratch that. That is absolutely wrong. Please do not do that. Look over at the right side. 5 squared is 5 times 5, which is 25. Your golden rule here is a number squared is always that number multiplied by itself. Never, ever just multiply it by 2. Let's move on to section 5, perfect squares in life. You might be wondering when you'd actually use this. Well, it's incredibly useful in real life. Let's say you're designing a beautiful, perfectly square garden. Step 1, it's 6 meters long and 6 meters wide. Step 2, you need to know how much grass seed to buy, so you calculate the area. You multiply the sides. 6 times 6 equals 36 square meters. And there it is in step 3. We easily see that 36 is the square of 6. You just use square numbers to plan a whole garden. Now, because squaring whole numbers gives us such neat and tidy results, they actually get a VIP title. We call them perfect squares. So numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, those are all perfect squares. They're whole numbers, no messy decimals or fractions in sight. So just remember, when you square a nice, whole natural number, the result is a perfect square. And finally, Section 6, Revision and Exam Questions. Let's get you ready for those top marks. Okay, here's a master list of the numbers 1 through 10 right next to the perfect squares. I highly recommend you just pause this explainer for a second, grab a notebook, and write this exact list down. Seriously, memorize it. Knowing instantly that 7 squared is 49 or 9 squared is 81 without having to stop and do the math, that is going to save you so much time on your tests. These 10 numbers right here are the building blocks for the whole topic. Now let's talk strategy. If your exam asks you to define a square number, here is exactly how you write a model answer to get full marks. First, confidently state the definition. A square number is the product obtained when a number is multiplied by itself. But wait, don't stop there. To absolutely guarantee full credit, always throw in a few examples. Just add, examples include 1, 4, 9, 16, and 25. Bam! That shows your teacher you completely understand the concept inside and out. Well, we have covered so much amazing ground today, all the way from visualizing chessboard shapes to writing tiny squared notations. But before we wrap up, I want to leave you with a quick challenge to test what you've learned. Is 49 a perfect square? And more importantly, why? Think back to those multiplication facts we just went over. If you can answer that, you are totally ready for our next lesson, where we're going to dive into some really fascinating secret patterns hidden inside these perfect squares. Thanks so much for hanging out and learning with me today. Keep practicing, and I will see you in the next explainer.